Okay, so we are looking at number 42 on page 437. So the last video told you to go ahead and attempt this on your own to see how you're doing. So we're going to put our PV equals nRT up here so we can see what we need to convert to. Now we have 2.49 moles of a gas according to this problem. It's contained in a 1 liter vessel and it's being held at a pressure of 143 kilopascal. Now, you can convert this over to ATM by using the 101.3 kilopascal equals 1 ATM. Or remember, we do have that gas law constant of 8.314 liters times kilopascal over moles times Kelvin. Okay, so you can go ahead and leave it in the kilopascal because we do have a gas constant, the R, for this. But you could change it over to ATM if you wanted. Some people want them all in the same ATM so that they feel comfortable. It's totally up to you. All right, so it tells us in the question, what's the Celsius temperature? So if we're looking for temperature, we have P, we've got our pressure, we have our volume, we have the moles, and we have the gas constant. So how to get to temperature? You're going to divide by NR to get T left alone. So I'm going to take my 143 kilopascal times my 1 liter. On the bottom, I had 2.49 moles, and we're going to end up multiplying that by the gas law constant of 8.314 liters times kilopascal over moles times Kelvin. Now, last time I forgot to show you how to cross off the labels. And labels are very important because as these get a little bit trickier, you want to make sure that you know where you're going. So let's cross them off. Kilopascal is going to go away. Liter is going to go away, mole is going to go away, and look, we're going to be left with Kelvin. Now remember, this problem wants degrees Celsius, so we'll take care of that when we're done, but this will get us to temperature. So I'm going to take 1.43 times 1, which is still 1.43, divided by left parenthesis 2.49 times 8.314, right parenthesis, and I end up with 6.907. Okay, this is Kelvin. Now, to get it to Celsius, we're going to subtract 273. Remember, 0 Kelvin equals negative 273, so we would subtract the two of those. So I'm going to take my 6.907 minus 273, and I'm going to end up with negative 266 degrees Celsius by the time we worry about sig figs, because there would be 3. So here is the temperature for number 42. Okay. 43, 44, and 45 would be the remaining problems that you would want to go through and do over just manipulating the ideal gas law, just like what we just did. The answers are in my answer key in my book, which you could either ask the substitute to look at, or you can ask me to look at before school, during class, whatever. We won't go over them in class unless there's one you specifically need. Now, I'm going to continue on with